Okay, hi everybody. Before I begin, I just want to do a quick follow-up on the token hunt thing that we'll do in the evening. If you're interested in participating, so we're giving out a total of 6 Ether in prizes and some NFTs and some tickets for Block Split next year. So if you want to participate, make sure you download the Status app before then so that you're ready, because the Status app is a dApp browser for your mobile phone that you'll use to access the application for hunting the tokens. You can find it on status.im, where there are download links, or just in the Play Store. So, yes, Billy?
Do we need gas?
Everybody will get $5 of Ether. Everybody who participates, I'll send Ether to everybody who signs up, so you have gas to send to pay for transactions.
Free money.
Free money. All right, so let's get started. I'll briefly talk about Ethereum 2.0 Serenity, the next version of Ethereum that's coming. And for those of you who was at DEF CON this year, so for those of you who were there, this is going to sound a little familiar maybe, because Vitalik held a similar talk about a vague roadmap. I'll go a little bit more into details, and I encourage you to ask questions. There's usually a lot of them in terms of the next stage of Ethereum. So you can ask them, like, if you're not shy, but just raising your hand at the end of the talk, or using the Slido app as mentioned before. Please don't hesitate to ask. There are no stupid questions. This is all very confusing for everybody, and I'll do my best to answer whatever I feel confident about answering. So I'm Bruno, and I'm the co-organizer of this conference, and I currently work at Status on the Nimbus team, where we're developing the next generation sharding client. So we're basically building a new node for Ethereum, which is focusing on Ethereum 2.0. So we're leaving Ethereum 1.0 behind in a way, and focusing only on the proof of stake side of things and the sharding things. So I work with the team on the protocol itself more than the actual app itself. The aim is to have the app use the Nimbus node behind the scenes when it's mature enough. I also run bitfalls.com and coinvendor.io, which is things you can check out. The first is educational, the second one sells crypto, and I work for some other projects. And Blockada.io is the NGO we formed this year to organize this particular conference, and Block Split in spring actually. So I definitely encourage you to check that out as well. It's a bigger conference, a little less developer only, but it's still very, very nice, and it's in beautiful Split, so you should definitely go. So let's get into it. The current problem of Ethereum is, of course, as we all know, the transaction speed. You have 10 to 15 transactions per second, which is not a lot if you want high throughput applications or general application blockchains in general. There's constant growth. You are constantly required to get new hard drives, better and faster SSDs to keep up with the input-output, and there's the heavy bandwidth that you need to sync up with the network. So running a node is getting more and more expensive. Of course, I mean running a full node, not just a light client or something like that. There was the CryptoKitties disaster of last year or the year before that. I think it was around New Year 2017, where one app kind of brought the network to a halt, and that was basically the best denial of service attack we could ever hope for, because it was benevolent. It was a positive stress test that showed us how much work we still have to do without actually attacking the network. So this was really fantastic, and everybody learned a lot from it. So a lot of new progress has been made since in that regard, at least in the theoretical space. And most projects use Ethereum to begin with for the completely wrong thing. So they will try to tokenize everything and anything. Even today, when the ICO space is dead, they will try to tokenize absolutely every single thing that they've had on their server up until now, which is kind of crazy. Last but not least, the current Ethereum is still on proof of work, which is everybody familiar? Who doesn't know how proof of work works? Okay, Steve. So yeah, it wastes a lot of energy. It kind of secures the network, but it opens the network up to centralization attacks and to censorship and so on. So definitely suboptimal. So there is some talk about Ethereum 1.x, which is kind of the midterm scaling solution in a way that will make the network easier to use in a way, cheaper, easier to maintain. So one of those ideas is rent, where your contracts, like right now when you deploy a contract, it's on the network forever, and you basically pay a gas fee once in Ether, and it will stay on Ethereum forever for everybody to access in perpetuity. That's obviously not ideal. Paying a one-time fee to store anything forever is not scalable. So the idea is to remove things from the blockchain, but keep their Merkle proof in blockchain. So you remove the data, but keep the proof that the data was there. So when you need the data, you request it from a full archive node that keeps it for you. That's going to be like from a provider like Infura or something. So there will be these custodians of old data that you can actually fetch from them, reproduce on the blockchain, and then restore if your rent expires. You can also kind of prepay your rent in advance, but I think we all know that if we want governments and other official institutions to move to the blockchain eventually, I don't think any of you know a person who hasn't run into a website from a government that has forgotten to renew its SSL certificate or hosting plan. So they're definitely going to forget to pay their rent on blockchain, especially because there's no way to send them email notifications. So you can expect a lot of dead government apps in the future. And there is going to be these custodians keeping an eye on this, and watchtower nodes that are keeping an eye on expiration for rent and so on, so that people can be warned ahead of time and renew their rent and so on. So you'll basically prepay like a debit balance to your contract, which will get deducted as the contract is used. That's one idea. There's also pruning and storage optimization. So there's this one guy, Alexei, who just basically took apart Geth, the Go Ethereum node, and took a look at how the data is stored in there. And he figured it doesn't have to be stored this way. He reformatted the structure, and he reduced the total data footprint of the entire blockchain's information that needs to be synced by like 80%. He's still working on this, and he figured out that he can now abstract a lot of, like, most tokens on the Ethereum network share a lot of logic, and he managed to abstract that to a further degree, where he reduced the entire tokens to a single abstracted contract, which they can all then reuse. So he saved a lot of storage that way, and he used the same thing for various DEXs, so decentralized exchanges, and the ERC 721 tokens. So he made some significant data savings there, and he'll be publishing. He's been publishing the work as he's discovering it, but he'll be publishing the final findings one of these days. And then there's EWASM.
Who's that person?
Sorry?
Who's that person?
That's Alexei. I forget his last name, but I can share it with you later. Yeah. And he's working on TurboGeth. Yeah,
he's part of the core team, right?
He's part of the core team. So you can, if you just Google TurboGeth, that'll be his version of Geth that's faster, that's optimized for storage, and you'll find him.
Thanks.
Then there's EWASM, which is the intended replacement for the Ethereum virtual machine. So the virtual machine that's running the code that people write in their smart contracts, that's going to be replaced eventually with EWASM, which is a subset of WASM, which is WebAssembly. So WebAssembly is kind of this low-level language for the web, because everybody's having trouble with JavaScript in lots of different ways. WASM solves that in a lot of other different ways and introduces some new interesting problems. EWASM is Ethereum's WASM, which is limited to a subset of WASM functionality to prevent some denial of service attacks and infinite loops and stuff like that. So the virtual machine is going to be sped up, the execution time is going to be cheaper, it's going to be shorter, so it's going to be cheaper to execute and so on. So there's going to be some progress there. None of these are finalized, these are just ideas at this point, and they're still being discussed. So this is kind of short to medium term, and they're pushing for this because they want some short to medium term gains before Ethereum 2.0 rolls around. So what's Ethereum 2.0? Up until June last year, there were 2 proposals for scaling Ethereum, for making it faster and better. And one was sharding and one was Casper. Casper was the proof of stake implementation, and sharding was the way to split the blockchain into different smaller segments of data that can then synchronize occasionally. But then they realized that they were kind of competing for miner interest or for validator interest, because you would either be validating shards or you would be validating the blocks produced by the proof of stake mechanism. So they abandoned this concept and merged it into what everybody called Shasper for a while. But then at DEF CON, Vitalik expressed his annoyance with the term Shasper and asked everybody to call it Serenity, so everybody's calling it Serenity now because everybody listens to Vitalik. So Ethereum 2.0 is called Serenity, and it's a bunch of updates that are coming in phases. So phase 0 is, actually we'll get to that, but the whole project is estimated to be completed somewhere in 2020. So we still have a long way to go. And it's not going to be an instant switch to proof of stake, so if you're worried about that or have miners or no miners who are, that's not going to happen any time soon. So they're going to coexist for a long time, the proof of stake and proof of work thing. Proof of stake is the idea that you invest some of your ether into securing the network and promise to behave. And if you misbehave, you lose that stake. So how do you behave or misbehave? You fetch data from the blockchain, you create new blocks, and you promise that these blocks are valid. You no longer do a lot of guesswork mathematically and spend a lot of electricity. Instead, you grab a lot of data, calculate something from that, calculate that the transactions are valid, tell about that calculation to everybody, and if everybody confirms it, you're good. If you're not good, then you're subject to slashing, which will take your Ethereum deposit away. So in order to become a validator on the new proof of stake network, you will need to have 32 Ether, and exactly 32 Ether. Over time, if you're offline, you're not going to be penalized as much as if you are dishonest. So if you lie about a block and submit wrong information into the blockchain, you will get a slashing that's much worse than if you're, for example, offline for 2 hours. You still have to maintain a very high uptime, so you probably shouldn't run validators on mobile phones or anything that's not connected to a stable internet connection. But in general, you will be able to, as long as you're online 2/3 of the time, you'll be fine. You're not going to lose your stake. So what happens when you lose your stake? You start losing it like bit by bit, and then the more your condition is unfavorable to the network, the faster you begin to lose it. So it's exponential. So it's in your best interest to stop doing what you're doing, what's happening, as soon as possible. And you will be kicked out. You won't lose the entire 32 Ether. You'll get down to 16, which is the minimum required to remain a validator, and then you'll be kicked out. So you will keep half of your deposit if you're maximally misbehaving, but it'll be locked for a few months. So you won't be able to withdraw the leftovers for a while. This protects a mass exodus and also allows people to time their exits and entrances into the staking network. So even if you're a good validator and you just want to exit so that you can withdraw your balance, you'll still have to wait a while until it becomes available. So everybody will be subject to this locking to incentivize keeping your stake in the network as long as possible and to incentivize running multiple validators. So you will be able to run several instances of the 32 Ether on one computer. You can also top up your balance. So if you start approaching the kicking out limit, you'll be able to top it up and get it back up to 32. And then you will be back in the game and validating as usual. The whole system is going to be reliably random. So we are going to have some sort of true randomness. How many of you are familiar with RANDAL? So, okay. So RANDAL is a way for a system that's deterministic. So in Ethereum, there's no way to generate random numbers because every miner on the network, whether that be the current miners or the future validators, has to produce the same data for it to be entered into the blockchain. If everybody's producing the same data, that means that there can be no randomness because the random number selected by one person has to be the same number selected by another person. Otherwise, their calculations of the blockchain will differ. And this is a very difficult thing to get around in blockchain because everybody has to have the same data. So RANDAO is this scheme where you commit to a number in advance. You as software or you as a human, you commit to a number, you imagine a number in your head, and you say, I got it, but you don't tell it to anybody. And then you have the reveal phase where you reveal which number you have selected after everybody has committed. So once the window for committing has passed for everybody, i.e. they can't change their mind, then everybody reveals, and from that selection of random numbers, a random number will be calculated. This is automated in Ethereum 2.0, and so this is kind of a still under discussion and slightly controversial point, is that we'll actually have ASICs, so machines that are designed to calculate, to make really fast calculations, that will plug into a network and provide this number, this randomness. Actually, they'll provide an additional committer, in a way, to this randomness to the network. So even if, because in the current setup, with RANDAO, where everybody is committing a number, the last person to commit still has a way to affect the outcome. They have only two effects they can issue on the network. So they can either reveal their number or not, and that's going to influence the randomness of the number finally generated in a little way. But it's still too much of an influence for the Ethereum developers to be comfortable with it. So they decided to implement these little devices that kind of upgrade the whole process and add another layer on top of that, making sure that the last one can't reveal last. So he will have to reveal, and then everything else will be calculated after his reveal. So the Ethereum network will have a true random number generation built in, and that random number generation will be used to select which of the validators is going to produce the next block. So it's all connected. The randomness will select the validators will build the block, the validators will also connect to something called the beacon node and so on. But it's all connected. We'll have true randomness, and you'll be able to use it in your dApps as well. So if you've been using something like raffles, lotteries, casinos, or anything on the blockchain, you will now finally have a source of random numbers for these gambling games that you can actually rely on. So validators I've covered to an extent, and the beacon chain is the last element that needs to kind of be explained. The beacon chain is the proof of stake blockchain. So the beacon chain is a separate blockchain that's going to be running alongside the current proof of work blockchain. There's going to be two blockchains. The beacon chain is the proof of stake Ethereum, and the current one is the proof of work Ethereum. To enter the validators pool, to become a validator, you send 32 Ether to a contract on the current proof of work blockchain. That will register you as someone who sent 32 Ether, and the beacon chain will read from that contract and see, all right, yeah, this guy committed 32 Ether and can now be a validator. The beacon chain will only maintain a list of validators and make sure that they are fine with their balances. It'll take them from the proof of work registration contract. So when you send 32 Ether to the registration contract, the beacon chain will just monitor that and add you to the list of validators available. This means that the Ether you send in is one way. So any Ether you send in to the beacon chain to become a validator is lost. You cannot take it out again, and yes, that means that there will be two Ethers. There will be one proof of stake Ether and one proof of work Ether. There will be two Ether tokens. Since it's one way, this kind of prevents arbitrage, but it still adds a layer of complexity for the period when both systems will be live. So, to become a validator, you take your current Ether, you send it to a registration contract, and it's effectively burned. It's lost. There's no way to take it back out again. It's on the beacon chain, which then considers you a valid validator if your balance, which you burned, is 32 Ether. If it's less, it'll just keep you in mind, but it will ignore you until your balance reaches 32. There is no way to take the proof of stake Ether out into proof of work Ether, but once shards happen, and they're gonna come in phase 2, so phase 0 is the beacon chain. Phase 1 is basic shards, but no transactions on them. So shards are like the hard drive of the blockchain, and we're just gonna have them exist alongside the beacon chain, but we won't be transacting over the shards. Phase 2 is then transactions, so that you can send data from and to shards and back again and so on. And only then will you be able to withdraw the proof of stake ether, and only to a shard. So you will not be able to take it back into proof of work, into the current Ethereum blockchain, even if it will exist alongside the proof of stake blockchain. So there's no deregistration. So that's worth keeping in mind. However, anybody who enters in phase 0 to stake for the sake of staking will get higher rewards, because the fewer validators there are, the higher the rewards, and because there's going to be a bonus period for early adopters so that we kind of test in production. So sharding, like I said, shards are data blocks, different data blocks off the blockchain which contain the data that is currently in the proof of work blockchain. So whenever you commit a transaction, that's stored on the proof of work blockchain and distributed to everybody. There will be 1,024 shards, no more, no less, and all of them will be equally distributed across the validators. So the randomness system will make sure that this is equally distributed. They are estimated to have kind of the exact same growth and kind of size potential. That distribution is still being worked out, but it should be fine based on that true randomness. The shards will communicate. So there's the active problem in sharding is synchronous communication. So the way, because in order to communicate from a shard, so the way shards work is one shard will contain addresses of a certain address space. So for example, every address from 0x0 to 0x1 will be on one shard. Now, most contracts and most transactions don't happen between addresses on the same space. So you'll have to communicate across shards. And that problem has been solved asynchronously. So one shard updates, then it communicates its change to the beacon chain. The beacon chain will keep an eye in phase 2 on the shards and will see, okay, you changed. And then we'll let the other shard, the destination shard, know. And this can take forever. This can take a very long time because you'll have to wait for the block time to resolve on each shard that you need to go through to reach the final destination. And if those have to go through many, many links in the chain, that's going to take a while. So the active problem there is slowness of communication between shards, and the synchronous side of shard communication is still being worked on. There are some interesting posts on ETH Research if you want to read up on it, but it's very technical, very mathematical. I welcome you to give it a try. And sharding will be, so like I said, in phase 2, when shards will be able to communicate, and then there's phase 3, which is the final phase, which is just optimizing everything that's been deployed up until then. And in 2020, we'll have a blockchain can basically really do what everybody else is advertising, so millions of transactions per second when you aggregate it all together. Because you'll get an upgrade by proof of stake speed, you'll get an upgrade by sharding, and then you'll have all the various other scaling solutions that are in progress. So what's going to happen to the proof of work blockchain once proof of stake is fully live? It is going to be, one of two things is going to happen. The current blockchain is either going to become a very big smart contract that is read-only. So it's going to become a snapshot from which you will read data that is archived. It's going to become available as a root smart contract. This is what Alexei is working on to reduce the state so that we can actually put it on the blockchain and not waste everybody's time and space. So if we can prune the data before that, that'd be great, because we'll have a very small archive contract that everybody can use from. The other approach that was discussed was turning it into a legacy shard. So it's going to become a shard in its own right, and then it'll communicate with all the other shards just like a regular shard. And it would still be secured by proof of work for a while, but then it would be easy to transition it to proof of stake, but the timeline hasn't been decided because the approach hasn't been decided yet. So the proof of work blockchain is going away, it's just not certain how and when, and it will live alongside the proof of stake blockchain for a good while, so for at least another year and a half. And of course there's the EWASM and rent thing, which is going to optimize things significantly. So with EWASM, you're going to have very secure and formally verifiable contracts that are highly optimized, so it's going to be much cheaper to run. And you'll have rent to make sure that people don't store all the junk up there. In the early days of Ethereum, when Ether was very cheap, gas prices were extremely low, and people were basically giving away Ether. Everybody committed a bunch of huge contracts to the network. Even now, if you just search the token list on Etherscan, you'll find 1 billion tokens. Those take up enormous amounts of data. So we are all basically storing everybody's junk. That will be prevented in the future. The new default will be, let's not store everybody's junk forever. Let's store the stuff that people want to store and charge for it accordingly. So it's going to be a different pricing model if you want to keep your data around forever. One of the major traits of Ethereum, I would say, is client diversity. So Bitcoin has a huge, huge problem in that 95% of their nodes are running one client. So that's Bitcoin Core, which means that the company that employs the developers that are developing Bitcoin Core controls Bitcoin because it gets to tell them what to do. It's very, very, very difficult to get a change into Bitcoin Core without approval from them, and they don't generally approve anything that their company doesn't tell them to approve. This is a huge problem, and this is something that from day one, the Ethereum core developers said that mustn't happen. This is why right now we have vaguely a 50-50 distribution between parity and Geth in terms of nodes. There's maybe 40-40 and 20% of other stuff. And that's way too low. So what we're doing with Ethereum 2.0 is we all started these various teams at the same time to develop 8 concurrent clients, and there's more people jumping on board all the time. Because now we have a specification that dictates exactly how Ethereum 2.0 should work, how the beacon chain works, how the validators work, how everything works in the entire system. It's all very detailed, and everybody's implementing from that list of instructions. So now we have chain-safe systems who are developing a JavaScript Ethereum client. They are completely aware of the ridiculousness of this effort, and they are not expecting it to ever be used in any production system. But it's a nice proof of concept and a reference client, if you will, for people who want to start developing their own based on someone else's code. Pegasus is developing a Java client. Harmony is developing a Java client. Parrot is developing their own Rust version of Ethereum 2.0. Prismatic Labs is developing Prism in Go. Sigma Prime is developing Lighthouse in Rust. Status is developing Nimbus in Nim. And the Ethereum Foundation is developing Trinity, which is the Python reference client. So this is the official client financed by the Ethereum Foundation. They're hiring developers to write the Python implementation. And everybody else who is trying to keep up looks at the spec and then looks at their implementation and then kind of combines those two into their own version in their own language or their own environment of choice. So these are the current ones that have kind of proof of concepts almost ready. The idea is we at Nimbus will have a beacon chain proof of concept ready at the end of December, so in a week. But those nodes will only communicate between themselves, so only Nimbus to Nimbus. For March, everybody has a deadline that all the beacon node clients have to be able to communicate with one another. So the main objective now is to make them able to find each other without depending on the DNS and using lib peer-to-peer underneath, which is a new kind of library of protocols to communicate peer-to-peer. And to communicate effectively so that they don't diverge in opinion about the blockchain. This is the March deadline, and you can consider Q1 as next year as the launching phase of phase 0, which is when we'll push to production the clients that can communicate through a beacon chain and validate with validators. That's when phase 0 will happen, and that is not when most people will be entering the staking system, because nobody has anything to gain except the people who are staking, and they have much more to lose if something goes wrong. So that's phase 0. Q2 is phase 1, then Q1 of 2020 is phase 3 maybe, and on from there. So what about scaling solutions like Raiden or Plasma and so on? All of those are still very much in progress. They're being developed by a whole lot of teams, but those are layer 2 scaling solutions that are not the core scaling, and they do hold much promise, and they will help a lot. Like a state channel between CryptoKitties at the time and between only its players would have helped enormously and would have solved all the problems, because people would have communicated just with their game and back, and then committed when they wanted to exit with their kitty or whatever. They would just close the channel, and that's it. So all the transactions would have happened in that isolated subsystem and would not have bothered the main Ethereum blockchain. But CryptoKitties had to happen for us to discover that concept and what it was good for. So these solutions are being developed, not by the core team, but by other teams, but they are no less of a priority because they are the ones that will be used in enterprise and in various commercial projects and so on. So it's just important to remember that Ethereum 1.0, even though it's called 1.0, it's still beta. And whatever you have right now on it can and probably will break. You entered the contract of smartness with Ethereum with the full knowledge that you're entering an experimental system and that you have no guarantee of long-term of longevity for your app, that nobody's promising it to you, and that you're at your own risk deploying something to production on Ethereum 1.0. So if we prune the data, there were, for example, a lot of apps, a lot of app developers realized that instead of saving data in smart contracts, which is expensive because it costs gas, they could save data in events in smart contracts. So events are logged into block headers in the blockchain, but they don't take up data. So they're just like messages in the blockchain, but they're not actually in the state. So they can't really be read by other smart contracts, but they can be read by applications from the outside. So what a lot of people did was they started saving the data into events. Instead of using events to receive a signal from their application that something happened, like a transfer happened or a function was triggered, they actually stored entire strings of data into events, which is much, much cheaper. And if we prune the events from the entire blockchain to save this space, which is currently occupied for no reason, then all of these apps relying on it will break. And that's on purpose, because we don't want to encourage abuse of the system. We want people to use it for what it's meant to be used for. And if they're not able to use it for the original purpose, we invite everybody to contribute with an opinion or a solution, but not as a hack that's harmful for everybody and for the network at large, because it increases every node's footprint and the data that you need to download to sync with the network. So Ethereum 1.0 is beta and will probably break. You should probably keep up with Ethereum 2.0 research and make sure that you're future-proof. It's not coming for a while, which means you have a year and a half to sync up your stuff and to be safe. It's not going to be a complete break, but a lot of stuff is expected to break, so please be aware of that. Dexes in particular. But Ethereum 2.0 is the real Ethereum 1.0, and I really invite you all to join us on this journey, to read the spec, to read the posts that we put out at Status, and to read the posts that I put out at Bitfalls for the explainers of 2.0. I will be putting out more and more tutorials on how to contribute to Ethereum 2.0, both from a discussion perspective and from a code perspective. You will be able to contribute to the Python client and to the NIM client, but a lot of other teams are also pushing out their own educational content, and we basically want to make this as approachable to new and coming Ethereum developers as possible, so that people don't develop it, don't take it the wrong way, and don't develop it the wrong way. Thank you. That's it. I'll take questions now.
So please put your questions in the Slido app.
Or raise your hand.
Or raise your hand. The code is 4383.
Can you off the slide?
I think so. What's the code?
4383. But yeah, I don't know where you want to put that. So the first question I have is, how are we feeling today? That's the first question. So is everyone good so far? Yeah. Thumbs up. Okay, great. Someone right here had a question. They had their hand up.
Yeah.
Question, Bruno, when you're ready.
Go ahead.
Okay, the question is about scalability and shard communication. So the goal is to have a lot of transactions per second. But imagine this, I'm writing some code and I'm using a library that is on some other shard, which then uses a library that is on some other shard, which is feasible, right?
Yeah.
And all of this should be synchronous.
Yeah.
And let's imagine one function call uses an amount of those calls. We still have to wait a lot of time.
Yeah.
So how do you imagine we'll solve the problem if we want real-time communication across shards?
I have no idea. This is something that's being researched in depth, and that's way out of my league. So I have no idea how to even think about synchronous shard communication.
Okay. And a sub question: just choosing shards by the address prefix sounds kind of silly.
That was just an example. We don't know how they'll actually be chosen, but it's the example most commonly used.
Yeah.
So this isn't actually defined yet because we're still working. Like phase 1 and onward stuff is still just like an idea. We want to get phase 0 right.
Right.
And then we'll work on the shards and stuff. So yeah, so this is all still very much in discussion. Like we have 6 calls per week on all of these aspects, and each of those calls takes 2 hours. And then everybody discusses this on ETH research, and then all of this has to be made into spec documentation, and only then can people go and develop. So this is changing every single day by a lot. Like I have 200 emails from GitHub in my inbox from just the Ethereum 2.0 specification repository. Catching up with this is a full-time job. So I encourage you to just read about the specific subset of things that you're interested in, because it's impossible to be absolutely literate in all of it. The sharding, I know some people have had some very interesting ideas. I have not been able to keep up with that part because we're focusing on the beacon chain and Nimbus, and we have a very strict deadline.
Thank you.
Sure. Yeah.
Yeah, I have 2 questions. One is regarding what Mateo already said, like, can you estimate the confirmation time in comparing the communication between shards and inside shards? But, like,
It's going to be a regular block time of like 7 seconds or something for a single shard. So that's going to be just like today, basically. And then you can just multiply that by the number of shards you need to hop to get to the final duration in asynchronous communication.
Yeah, but in terms of confirmation time, if I'm doing something off chain and I want to make sure that
I mean, it's the same thing. Yeah, you just upload it to the shard will finalize it, and the validators who are validating that shard. So a validator will be responsible for 1 to 2 shards. On a standard computer at home, you will be able to run something on the order of 9 to 12 shards. Because in order to run shards and to validate on those shards, you need to download the data of those shards. This incentivizes mining pools, staking pools, because they need to have much beefier hardware to maintain that. And so there's this two node concept. There are these 2 types of nodes. So these are validator nodes, validator clients, and beacon nodes. Right? A beacon node will take a shard's data and pass that data onto a validator for the validator to create an attestation. So the validator will take the data, calculate and do an attestation, create a block, and submit it back to the beacon node to include in the blockchain. All the other validators will chime in and either verify that block or reject it. And then the block gets either created or the validator gets slashed and kicked out of the network eventually. And all of this happens in regular block time. So you will basically be running a validator which will take your transactions, it'll seal them into the attestation, it'll send them to the blockchain, and that's going to be one block. That's not going to happen in one block. So then it will communicate to the beacon chain will communicate it to the other shard, and so on and so forth. So yeah, the number of shards times the number of the block time.
And the second question was about gas. You talk about, I don't know, lowering the gas cost for each opcode, or will it have higher or lower gas price if you have
the gas prices are going to be lower because it's going to be WASM. So it's probably going to be much cheaper to execute stuff, but it's probably going to be more expensive to store stuff long term. So we'll see what they'll decide. There still have to be some metrics and benchmarks and so on. I'm sure people will compare the current state of the blockchain and rerun it on E-Wasm to see what happens and how much that costs, and then we'll see what we can do with it.
Which scenarios can we expect, and what can go wrong? What can go wrong when the upgrade will happen? Forks, something that we maybe didn't foresee.
So there's not going to be a fork. There's no fork. This is not. So like I said, it's two parallel blockchains, two completely separate blockchains that just share a name. So whatever happens on the proof of stake blockchain stays on the proof of stake blockchain, and whatever happens on the proof of work blockchain stays there. There's no forking involved. We are going to keep forking the proof of work blockchain to upgrade it, like the Constantinople hard fork that's happening in January. But it's not like one will have an effect on the other. In fact, we might use the proof of stake validation to actually additionally secure and finalize the current proof of work model, so that we can actually start phasing out the miners. Because if we launch the beacon chain and people start staking, then we can, and we don't have shards yet, then we would basically be producing empty blocks of junk data. But if we can turn that around and make sure that instead of validating empty data, we validate the blocks from the proof of work blockchain, we basically add a new security layer on top of the current proof of work blockchain, which keeps existing, which makes the phasing out of the proof of work blockchain easier. But in terms of what can happen, when time comes to turn off the proof of work blockchain, it's going to just become read-only. And the easiest way to do this is, if you're a dApp developer or smart contract author or whatever, you just keep an eye on the timeline and be ready for it, and move your stuff to the new blockchain as it becomes available alongside the old blockchain. So for example, Augur is making all of these prediction markets all the time. And there will come a time when they will no longer be able to write on the old blockchain to make a new prediction market. But for a good while, they will both be alive at the same time. So what they can do is they can just switch in their code, make sure that every new contract created from that moment on is created on a new blockchain. To the user, this is going to be like unnoticeable. The user is going to just keep using the blockchain as he used to. Augur is going to, behind the scenes, be targeting a new blockchain. That's it. So there's no, I mean, if you've got any kind of architecture that's, you shouldn't be using a single smart contract for a very long time anyway. You should be able to reset your smart contract every once in a while. So once that happens, just consider moving it to the proof of stake blockchain. And if you have a system that depends on a long-living, super long-living contract that just keeps growing, maybe rethink your architecture, because that's not how it's supposed to work. So when it happens, just move your stuff, move all your newly created stuff to the proof of stake blockchain, and it'll be fine. Yep.
What sort of guarantees of finality are there on the proof of stake chain?
Well, there's the Casper LMD, which I have not been able to the Ghost LMD, which I've not been able to digest properly. But it's the last message. I forget the abbreviation. But anyway, it'll select it won't select the longest blockchain. It'll select the longest blockchain, the longest chain of signed messages from different validators off that shard. So it's going to prioritize the input from validators who agree, in a way. There's actually, if you look at Vitalik's blog, I think the last post there is a computer science guy friendly, I won't say newbie friendly, computer science guy friendly explanation of Ghost LMD and the probable finality gadget that we'll use in the proof of stake blockchain. That's not sure either. So that's currently the best candidate, and nobody's been able to offer a better solution. But even that's subject to change. So we have really no idea. Like right now, when the beacon chain is being implemented, we're not even going to focus on that. We're going to pick the simplest option, which is the longest chain, and we're just going to make sure that the clients can communicate right at the stations and build blocks. And then later on, when the academics chime in, because it's pending reviews and whatnot, then we'll see if the LMD Ghost actually works or not, and if that's going to be the finality approach that we use. But yeah, I can't tell you more. I'm not knowledgeable enough there.
Is it good to use VPS for validation in Serenity?
No. So when you're validating, you want the lowest possible latency, and VPS does not help with that. Second thing is VPS doesn't actually help with anything more or less, because everybody keeps logs, and if they say they don't, they especially do. And you will actually be subject to kind of attacks if you route your validation through someone else. So they can, this is very risky. This is just trusting a third party to forward your requests to the blockchain when you depend on those requests reaching the destination safely in order for you not to lose money. You definitely don't want to relay that responsibility to someone else. So don't use VPS. We will have validator privacy. So a big concern was validator DOS attacks, where people would be able to detect on a network who's a validator, then DOS them, and this would force them to go offline and they would lose their state. Validator privacy is being worked on, so validators will be masked on the network. But beacon nodes, the nodes that the validators connect to, won't. So this is an ongoing problem. How do we hide the beacon nodes and still prevent the formation of huge beacon node SaaS providers like Infura? Because that's definitely another thing that we don't want. So the mantra of Ethereum 2.0 is to be World War III resistant. Really, that's in the specification. World War III resistant. So if most of the validators go offline, most of the beacon nodes go offline, if only one of those VDF ASICs that's producing the randomness remains alive, we're still good. So all of the spec up until now has been World War III resistant, except the beacon node idea, which I'm actively discussing in the specs and raising issues about. It's a big issue, I feel. Others don't seem to agree, but I feel it's a big issue, and I don't want to see Infura-like SaaS providers of beacon nodes that every validator will be connecting to, because then we've got the same problem we've got now. Everybody's using Infura, nobody's hosting their own node, and people don't have incentive to run their own firm nodes, so the network is decreasing in security. We'll see how that works out. Yep.
You were discussing this problem with centralization with Infura-like providers or so. It seems to me that we're kind of struggling to move away from this centralization, but we have a bunch of decentralized software. We see in Bitcoin, mining power is centralized. We see in Ethereum, we have services like Infura. I think that we have some systematic problems with human nature and not so with the software.
The problem is laziness. It is incredibly difficult to run your own node. It is extremely expensive. It will, make no mistake, burn through your SSD. Like Ethereum will destroy your SSD. It's like in terms of I/O, it can do. It's gonna run out of life in a year. It's very expensive, very difficult to keep running, and you need to have a team to professionally run full nodes. It's not at all cheap, and that's a huge problem. It's gonna get much better with the beacon stuff, because in particular on Nimbus, we're focusing on super low-end devices. So you're going to be able to run Nimbus on your smart oven, on your whatever, doesn't matter. Nokia 3310, because it compiles to everything. But that doesn't mean you'll be running a node. You'll just be running validators. Nodes in particular, I have no idea how we're going to solve. I would prefer a solution like the VIP node that's active right now, where you kind of prepay. If you have a light node, you prepay for access to a full node which someone else is running. So you basically pay for a slot. A light node is a node that doesn't download the entire blockchain. It connects to another node which lets it verify the stuff that it needs to verify. So it's not just an API call that trusts the result. It's an API call that requests the data, that lets the node make sure that the result is true. And right now, there are not many nodes that are running light node slots. So in order to connect to a full node, the node has to have a slot for you to connect to, because otherwise the node would get overwhelmed. And there's a huge problem, a huge lack of full nodes with light node slots. So people came up with the concept of paying for VIP node access. So for full node access, you pay in advance with a smart contract to reserve a slot for your node on that full node, and then you can connect your light node to that full node, and that works. This does expose that node in particular to risk, because it publishes its IP publicly and people can DOS it. But it helps with light node access, and it incentivizes running full nodes, which are currently not incentivized at all. So that's a problem that I hope we'll solve soon, but I don't know how. Anything else here? Will all the current proof of work tokens be burned at one point and transferred to the POS chain once the proof of work chain is archived. So the fact that it's archived doesn't mean that it's going away. That means just that it's going to be read-only. So the balances will stick around, but in order to move them around, yes, you will have to move the balance of the contract to the new blockchain. If you just, like, a bunch of the tokens that exist right now have zero liquidity, so they don't move at all, those will probably stay in this read-only phase forever if they're not pruned altogether, because they're obviously experiments from the early days. Other tokens that are being used are just encouraged to transfer over all the balances to the proof of stake chain, which is just one command, because everything is saved in one contract anyway. So you just transfer that over, that's one call, and it's done. That's not going to be a problem at all. Anything else from non-shy people? No? Yeah?
Got another question about randomness. So you said that there will be another layer of commitment to like guarantee better randomness.
Yeah.
Because if one guy could flip the result.
Yeah, his binary, like.
Yeah. Okay. So not much, but the question is this: if we use hardware on top of already existing systems, it sounds to me like it's some kind of trusted hardware. So the question is, how does that work? How can we guarantee that that hardware is indeed running verifiably random stuff? And do we need to trust the hardware providers?
Okay, so the hardware is not actually running randomness. That was just a simplification on my end. The VDF and the VDF it's randout plus VDF. The VDF stands for verifiable delay function. So the hardware device that you plug in basically makes sure that there's enough of a delay between the last committer and the time when it's time to reveal that he cannot choose not to. So it's just a delay, it doesn't actually add anything to it, but it causes this delay by making a calculation that is complicated, but verifiable by every device because it's not a race, it's not proof of work. It's just a formula that everybody can calculate, and as long as one of them is honest, you have the result that you need.
Is it the same as in Hyperledger Sawtooth?
I don't know about that.
It has some kind of hardware that manages to derive verifiably time delayed stuff.
That's probably right.
Which implies trust in hardware producers.
The thing is, the hardware in question is already open sourced by the Ethereum Foundation, and a lot of other blockchains have joined the effort to finance the development of these chips. So everybody else is involved as well. So all of the blockchains are collaborating on this, even directly competing ones, just to get a verifiable delay ASIC out, so that everybody can use the same thing, and that should help a lot.
If it's open source.
It's open source. It's fully open source. Okay, I think that's it. Thank you very much, and enjoy the rest of the conference.